Hey, what's going on, folks? It's Mike here, and welcome back to my D Programming Language series. In today's episode, we're going to be talking about D's module system. So we've been using modules, we've been doing a lot of sort of single file programs here, but I want to talk about when you scale up, how D's module system helps you. Now, if you're coming from a programming language like C or C++, where you're used to having source files and header files, which sort of define the implementation and the interface, D basically just has modules. Now, you can, of course, define a D interface file. So if you have some library code that you just want to expose the interface and not the actual implementation, you can do that, no problem. But most of the time, we just end up using the module system in D, and it works really, really well. It has a bunch of benefits, such as being able to compile things without worrying about the order, without the sort of declaration order. So there's just a bunch of different advantages to the module system, and the major one is that it's very, very fast. So compilation in D is very, very fast. Let's go ahead and take a look at the feature here. And I'm going to go ahead and start us off with a D programming language website here, and we'll go to documentation, the language reference, and let's go ahead and take a look at modules here. So for today's episode, we're just going to focus on the module declaration and see how that works, how naming works, and why it's a good idea to usually put module at the top of your file, as various tooling and so on might depend on it. So what is a module? Well, a module has a one-to-one correspondence with the source file. So per source file, you have a module. Now, if you want to group related things, that's going to be called a package. We'll talk about that, so stay tuned for that in an upcoming episode where we'll talk about packages, which are going to be very familiar if you're coming from a world like Java, for instance. D has sort of the same setup. But we'll do some examples again in a video coming up. So again, a module basically defaults the name of the file. So we haven't really had to worry about this. And again, as I mentioned, it's usually going to be a good idea to name our modules, and they'll probably match the file name anyway. So the way to think about a module too is this is sort of the default encapsulation unit in a D program. Again, if you're coming from a language like, let's say, Java or C++, oftentimes we kind of think in terms of like classes, how we organize things, but a module is sort of our scope. Okay, so any variable, anything that I create could be scoped within a particular module. This is kind of nice because then you always have some sort of encapsulation within each module, and it kind of organizes your code in a much more clean way versus if I have just, for instance, a global variable that's hanging out somewhere. I know or can reference it based off of the fully qualified name of the module. So I'll show some examples of that coming up. So again, a module isn't a class. It has nothing to really do with that. And you can kind of see the reasons or why it's different. It's basically just a way to encapsulate a bunch of functions, user-defined types, variables that you might have declared, and so on. And this also leads to some very interesting repercussions, or I should say advantages with some things that you can do with modules. Like you actually have module constructors and module destructors. So what happens when your program starts up or when your program is shutting down. So very briefly, I'll see if that is in the, that is in part of the documentation here. So we'll touch on that just a little bit as we get into this video. So anyways, let's go ahead and start playing around with modules. Again, naming conventions, usually lowercase, maybe some underscores, but I try to keep the module names relatively simple. Let's see here. And here is basically the declaration here. Now, you'll notice that in this particular example here, there is a C dot. So that means this is module stdio in the C package. Okay, so C is a package, or it's a directory containing this module or this file name, because again, remember, there's a one-to-one correspondence between a module and a file. And usually we name that file name the same thing as the module declaration here. So somewhere in a directory called C, you have a file named stdio.d. And you don't have to include the .d when you are typing in module. That would be kind of redundant because, again, that's not really important. D files end in the .d extension. So we're just going to kind of ignore the extensions. Okay, so, and there's a couple other interesting things we can do to, and I'll show this an example, but I just wanted to go ahead and show this here, where if you're transitioning old code, for instance, or have a module that you're rebuilding, or maybe a new version of a standard library or something, exciting like that, you can actually deprecate modules, which is cool because it lets you use the actual module, and you can use this on other sorts of features, the deprecated keyword. But this will basically warn the users that, hey, some of this code is going to be replaced later. You can use it for now without any errors, but we are going to give you a deprecation warning here. And again, this is one of the real reasons these sort of features or this collection of features in the deep programming language, this amongst other things, it just makes it a really nice language to work with. So anyways, we'll get into demonstrating that. Let's go ahead and take it from the top though, and just write our first little module here. So again, you can see I just have a empty directory here. Let's open up the main file here. I'm going to import a module here. So we've been doing this basically all throughout the series where we've been printing stuff out, but from, again, somewhere there's a package, our standard library. That's the Phobos standard library version 2 at the time of this recording. And then we have the stdio, or standard input-output library, that we've been importing. Okay, so this is a file somewhere. We should be able to search it. And if we look in the directory structure, it's part of the standard library packet. And again, just to make that super concrete, let's bring in, if you search for the standard library here, Phobos, which again, D is a open source project here. Let's go into Phobos. Let's go into the folder std here, standard. And if I search stdio, we can find the .d file corresponding. Okay, so hopefully that makes sense here. Again, you can see the structure here in this directory, this file, and then you can read the source code. And it's actually pretty readable source code, which is, again, a testament to the language here. So let's just drop that in here. So again, that's what we're looking at here when we have standard stdio. So now you know the module here. But you're probably interested otherwise in writing your own module. So let's go ahead and give us another function here. Let's just write a little math library here, as I sometimes do here. Let's just sum up 2 integers here. And of course, we could make this generic by adding them and so on. And if I want, what I can do here is, let's just go ahead and import math here. And let's go ahead and call this sum function here, okay? And just to make it interesting, well, let's just call it sum here. So let's write line here. I'll do sum. Let's do 2, 3, something like that. And sum 2, 3. Let's go ahead and give this a compile here, RDMD. Let's run main here. I'll go ahead and do it. And it looks like it's calling our sum function here, okay? And if you want a little bit of I don't know, confidence that this is working here, it's never a bad idea to print out my, some function, or you could give it a name or something. And again, you could see that it's running here. All right, so generally speaking, it's as simple as that. Now, a few things that you might run into, let's say I'm trying to compile this program. I'm not using RDMD. And if I run DMD here, let's go ahead and kind of highlight this error, because this is a common sort of beginner thing that I ran into and got confused here. If I try to compile this in the same way that I was doing right with RDMD, my program runs here. But when I'm trying to compile it, it's saying, hey, undefined reference to this math function here. Don't forget that you want to provide all the modules that you're compiling here. Okay, DMD, and then we should get this output name here, and now it's going to compile and run here. Okay, now if you read the rest of the error message, as you should, you'll see that I can use DMD-I, and that's kind of behind the scenes what RDMD is doing, and that will, as it finds these imports, bring in these modules, which is very nice. I like to, or I tend to, if I have a larger D program, just pass in everything so I don't have to make the compiler do any work here, but it's basically doing the same thing, and it simplifies the compilation process quite a bit. So again, probably no reason, well, I'd maybe need to think about reasons. Maybe some of you folks know, you can comment below of why to do it one way or the other, but again, this is just a little thing here with imports and working with modules, and we will talk more about imports in an upcoming video, as well as packages, as I mentioned, just to put everything together. Okay, so, this worked nicely here, but again, as I mentioned, we probably want to do module math here. As I mentioned, matching the file name with the module name is a good practice here. Why is this a good practice? I know some tooling, like even DDoc, which we will, again, talk about in a future video, which is the built-in sort of documentation generator with the D language. I believe it uses, some of these statements here to help generate some of the documentation and kind of organize things. So it's good for tooling to have this in the actual source code. So I should be able to compile and run this no matter which way I want to do it. Let's just do it with RDMD for now, and it'll work just fine here. And then later, if I do my math here and run it, it's going to complain. Error module my math from file math.d must be imported with, import mymath. That's actually a pretty good error message here. Let's go ahead and do mymath here. It looks like I was able to figure that out here. Let's see here. Let's make sure I save everything. Let's see if that did the trick here. Now it's saying unable to read module mymath expected mymath.d or mymath.package. So you can see we are getting in trouble here when the names don't match here. So maybe that's stronger than the convention. Maybe that is a hard and fast rule here. Let's go ahead and change this back here to math. That's totally fine here. Okay. So I've got my module math here. And again, we followed best practice by naming it the same thing. And let's say, I want to use some other functions or write some other variables or something. Like let's, go ahead and give ourselves like pi, I don't know, 3.141, something like that. And let's go ahead and write it out here. Math.pi, or let's just write out, math.pi is, and I'll show you why I'm writing that out in that way here, right? That is kind of just showing us the scope here, that this is part of the module. Okay, so you can effectively, if it's useful for you to visualize here, think about, your module, which, this declaration comes on the first line here, okay, the very first source code line. You could kind of think of it as just wrapping up everything in a scope here, okay? If that's helpful for you to think about the naming here, math.pi here, okay? But you don't need those curly braces there. Okay, so what we got now is this pi variable here. We've got our sum function, which is very handy. But let's say, again, we're writing a really large piece of software here, and a user also imports from the standard library, math. And I like to keep my declarations sort of together here, or my import statements, rather. And now I try to run this. So let's run this, and it's saying, okay, conflicting symbols here. Because if I look in the standard math library, it's got a pi symbol defined here, okay? So how do we fix this? Well, a couple ways we can fix this, and the easiest is to just say which symbol we're actually using with the fully qualified name here, and that fixes the issue here. Okay, so we can see the standard library math.pi version, and then we can see ours here. Okay, and of course the standard library has more precision. I think it's probably defined as a double or maybe even a real value, but there you go. So you can see that our version in the math module versus the standard library one. Now, let's say that our math library, again, is no good. We trust the standard library, which generally we should trust the standard library in most programming languages. So I can then mark this as deprecated and say, well, our code can compile. It still runs, as you can see here, but we've deprecated this module here where we've included or imported this rather at line 3 here. So it's going to give us some warnings here on this entire module here if we've imported anywhere. Okay, so now we know, like, hey, set up our contingency plan to replace this or whatever. So that can be a really handy tool if you're writing libraries, again, which is where, the module system really thrives for splitting up your code and, kind of keeping things organized. Again, I just really like having some of these indicators in the code because ultimately the source code is the source of your truth in any given program. So, if this says it's deprecated, then it's deprecated. So I want to show one more example here, and I'll leave this deprecated here, but let's create some other variable here that's maybe just global in scope here. Let's just call it X for, lack of a better term here. And then let's create a local variable here, also X, and try to build this here. And let's see, this seems to be okay. And again, just to look at some different variables here in different modules, whether they're from the standard library or not. Let's go ahead and write these out here. And let's assign them something like 57, and let's do, 50 or 24 here. I'm just hitting random values here. And I want to write out X is, let's see what it's going to actually pick up here. Okay. Okay, so 57. So it's picking up the local scope here. And again, that's because if I want to refer to my math module, let's do my math, or just math is fine here. Oops. Let's make sure we save here. Then we'll actually pick up, 24 here. So again, these rules hold wherever, they are. If you're shadowing like a parameter from something locally here, then you will get a warning from the compiler about shadowing. But since there is a module system and there's a way to refer to a specific variable, again, you might just have to use the fully qualified name. So again, something you might run into if you're seeing weird results. Just a little tip here: even if I do have a module, I still sometimes like to wrap it in like a structure or something, or maybe this will be a different file. So this is a little trick that I've learned just reading through source code. I've listened to some, I think Attila gave a dconf talk about this a few years ago, also using this trick. So I would just create a module called globals and define some of these things if you must have them. So anyways, that's just a little note there on that. Okay, so the last thing I want to talk about with modules, let's get rid of those X's here, is this feature of the constructors and destructors. I might actually do this a more in-depth video because this is going to be important for also classes. But let me just show you a very brief idea here that for your module, you can just define this constructor here. So let's look at the documentation here. So again, basically a module, it's functions, even this function, right? You could put a static word in front of it, right? That's kind of how all these functions are defined, right? They're static. But anyways, you have a static constructor and destructor. Okay, so that's why you have the static word in front of this here. And I want to talk more about shared as well. But let's just do a simple static this here and a static this destructor here. In our math module, let's go ahead and let's write out a little message to the user. Bringing in math, so we can put in some message, and let's go ahead and say cleaning up math, okay? And let's go ahead and say like globals or something, right? Because maybe we have some global variables that we need to delete, and that would be a purpose of having this sort of, constructor and destructor. Maybe this is a pointer to something interesting, right? So that's kind of the idea here. So anyways, let's run it. And you can see clearly, before our program starts here, we're bringing in math. And at the very end of our program, we're doing cleaning up math globals, okay? We could do this in our main program. So again, our main is down here, lines 1 through 10. Let's go ahead and just add a static this. And I'll write the line here, main. Just to, again, show this point here. Let's do the destructor as well. Static this. And I'm just going to write line here with a little destructor symbol in front of main. And let's go ahead and see if we can get that going here. I'm going to move these just to one line. This isn't a great style, but just to show you what's going on here. Again, that you're bringing in your modules. Now the ordering here, I'll cover in the other video here. I believe this is defined here. The order of static initialization is determined by the import declarations in each module. Okay, so since I'm importing math first here, that's going to be called. Okay, so if that order matters here, and then your main function, and then it's sort of like the last in first out order of destructors here. So then main's going to clean up, and then globals, and so on. Okay. So anyways, we'll take a look at that in future videos because this can also be used for things like classes as well. But that's kind of it to modules. It's a really great system, makes things fast. A lot of people don't even really use makefiles because it is just so fast to compile. But you can use makefiles if you want as well, and maybe you get even more speed from that sort of build system. I'll have to test on a large project, and I'll be curious if folks are using build tools alongside the module system to get even more performance and so on. So anyways, I think D has a really clean module system. I like using it. I think it's a great way to program. And again, if you really want, you can just have a D interface file that defines your sum function, and you just import that. And then you'd link in your compiled code as normal. Maybe we'll talk about that in a video. If folks want that video, let me know. But otherwise, for all the videos that I do have and more, you can always check those out on courses.mshot.io here on the D programming language series. There's a bunch of other stuff as well that you might be interested. So go ahead and feel free to check that out. All right, folks. So thanks for your time and attention. Hopefully you enjoyed this video. And otherwise, I'll look forward to seeing you in the next lesson.